Hello. Read this problem. At the instant shown in the figure, end B of rod AB is moving rightward along the floor with velocity 3 meters per second. Determine angular velocity of rod, velocity of end A of the rod, and velocity of a point on the rod 4 meters from end B. Now listen. If point B is moving rightwards along the floor, this is not stationary body. The rod is moving. And end B is moving rightwards, so we are sure that end A is sliding on the surface, vertical surface in the downward direction. It's impossible that B is moving rightwards and A is moving upwards. The rod will not get elongated. So B is moving rightwards and A is moving downwards. We can visualize that. So let's draw a diagram of this rod in motion and we'll show velocity vectors, non-linear velocity vectors in the diagram. So these are the two vertical horizontal surfaces. Rod AB, angle of inclined members always required, so show that angle 65 degrees. And all dimensions, label the rod. So all information we have in the diagram and linear velocity vectors which are known will show in the diagram. So it is 6 meter long rod. Velocity of end B is 6 meters per second. Just draw line diagram because geometry is involved. No shading to the surfaces. Draw very faint line for the surfaces. The body under consideration is rod AB. Draw it with a single line. Insert all given dimensions. And if B is moving rightwards, we are sure that A must be sliding downwards along the wall. So VA, we don't know magnitude of VA, but direction of velocity we know. Are you sure the rod AB is in rotation? Yes, we are sure that rod AB is in rotation because 2 points on the rod are moving in different direction. Now try to understand. Here it is a rod that has a fixed center of rotation, It has a hinge support and hinge is fixed to the ceiling. So this rod can rotate about its upper end only. So this is case of fixed center of rotation. If you try to visualize a motion of the rod, this is the motion you can visualize. It has fixed center of rotation. But in this case, in case of rod AB, there is no hinge support, means there is no fixed center of rotation. But we are sure that rod AB is in rotation. And we know how to find center of rotation of this rod at this instant. Because center of rotation lies on perpendicular drawn to velocity vector at corresponding point. So draw perpendicular to VA. Watch here, check this notation. Perpendicular to VA, it's not perpendicular to rod, it is perpendicular to VA at point A and draw perpendicular to VB at point B. Where these two perpendiculars intersect, that is ICR. Now non-linear velocity vector about ICR gives the direction of rotation also. Tilt this arrowhead towards ICR and you get the direction. It means at this instant rod AB is rotating about this point, IAB. I for ICR, instantaneous center of rotation. We are going to label ICR with letter I. IAB means center of rotation of rod AB. So rod AB at this instant is rotating about this point. This is the center of rotation of rod AB at this instant, and rod AB is rotating in anti-clockwise direction. Can you visualize this motion? Let's try to visualize this motion. Watch here. End B is sliding rightwards from the wall, away from the wall. So watch here, initial position, and I have taken a photograph, imagine, at certain position. Have you noticed that during the motion, angle of rod with ground is changing? Yes, that means there is angular displacement, and angular displacement means a rotation. And check again, you will understand now that rod AB is rotating about a point somewhere here. Check. So about this point it is rotating. So that point we have located at this particular instant given in the diagram. But you have labeled a point as ICR doesn't mean that you have found out ICR. You will have to find the distances of point ICR from reference points. So RB is distance of B from center of rotation. RA is distance of A from center of rotation. Which triangle has these two sides? Now, of course, distances, angles you will get by triangle geometry. Which triangle has these two sides, and you will able to focus on the triangle. So focus on that triangle and check what information you have about this triangle. Do you remember I have told you two sides, one angle, or two angles and one side, or all the three sides? That is what you should know if you want to find other angles or distances from that triangle. Now in this case, let's check it. 90 degrees, one angle is known here. This angle is also known. How much is that? 90 minus 65, that is 25 degrees. So two angles and one side we know. So you will able to find RA and RB, and it is right angle triangle. So sine, cos, tan, Pythagoras theorem. Let's check it. Here hypotenuse and adjacent side. So RB is 6 cos 25 and RA is opposite to 25. So hypotenuse sine 25. So RB is 5.438, simple, 6 cos 25 and RA is 6 sin 25. It's simple right angle triangle. So we have found out RA and RB. So we have solved the problem nearly. Now calculations. As I told you, in these are problems on general plane motion. Remember, general plane motion, that is a rotation but no fixed center of rotation. So once you locate the center of rotation at the given instant, we don't know angular velocity. So start calculations with known linear velocity. So VB is equal to RB into omega AB. So put the known values. VB is 6, RB is 5.438. So we have found out omega AB. Incomplete answer. Now direction. So direction we have already identified. So show that direction in the answer. So this is how angular velocity of the rod we have determined. Now VA you want to find out. Simple. VA is equal to RA into omega. RA is 2.536 and omega is 1.103. So we have found out VA, and direction is also known to you. Just show it in the answer. So VA, simple. Once you get ICR, you will able to find velocity of any single point on the rod. Say you want to find velocity of midpoint, say M. So Vm is equal to Rm into omega. Simple. Now what is asked in this problem? Velocity of a point on the rod 4 meter from end B. So there are of course infinite points on the rod. We are asked to find velocity of one point on the rod which is 4 meters from end B. So let's locate that point first. So 4 meters from end B, I have labeled a point as point C. So remaining distance, that is distance or length AC, is 2 meters. So total length of the rod is given 6 meters. Now once you get RC, you know that VC is equal to RC into omega. Once you get RC, you will get the answer because omega AB is already known, and to find RC we are going to use geometry of triangles. So RC is line joining point C and ICR, distance of point C from ICR. So this RC is to be found out. Which triangle has this side RC? Ask yourself this question, you will able to focus on the triangle. Now question is, can we use this upper triangle? Of course, that also can be considered because RC is one of the sides of this triangle also. So any one of the two triangles you can consider. Let's focus on the highlighted triangle here. What information you have? Two sides, watch here, this side BC and length BI, I for ICR, length BI and length BC. These two sides are known and angle between them is known. So two sides and angle between them, immediately cosine rule will strike you. So use cosine expression and get RC. If two sides and angle between them is known, third side can be found out using cosine rule. So RC is equal to 4 squared, what formula you are using? A squared plus B squared minus 2AB cos theta. So 4 squared plus 5.438 squared minus 2AB, 2A is 4 and B is 5.438 cos 25, and you will get the answer. Calculations no problem at all, and geometry is really also no problem. Just draw diagram carefully, freehand sketch, but insert dimensions carefully. Any side or angle you want to find out, ask yourself this question: which side has which triangle has this particular side, or which triangle has this particular angle, and you will able to find out that. Now, one more instruction I have given you in first lecture, if you remember, and what is that? If you have found out R by studying geometry of a triangle, then use the same triangle and find angle of R. In this case, we have found out RC using this triangle. So, in this triangle, we will find angle of RC also. Now, why angle of RC is required? Simple. VC is perpendicular to RC. If RC makes angle theta with vertical, VC makes angle theta with the horizontal. So, in this triangle, now let us find this angle theta, that is angle of RC with vertical. So, of course, use sine rule. So, RC upon sine 25, RC to be found out, divided by sine of opposite angle, that is equal to 4 divided by sine theta. Now, put RC as 2.479 and you will get value of theta as 43 degrees. So, we have found out theta, and now again VC is equal to RC into omega. Put value of RC 2.479 and omega is 1.103 and get the answer. VC is equal to 2.734 meters per second. This is magnitude and direction. Remember, you will able to show direction correctly if you show vector VC in the diagram. If you show vector VC in the diagram, there will be no mistake in identifying direction of VC. So, VC to be shown at point C, perpendicular to RC. Perpendicular to RC, but why downwards? Why not upwards? So, remember, VC also must give you anti-clockwise sense of rotation. All points on a rotating body suggest you the same sense of rotation. If body rotates in anti-clockwise direction about a point, then all points on the body, it means all points on the body move in anti-clockwise direction about that point. Remember, VC is not along rod, VC is perpendicular to RC. And if RC makes theta with vertical, VC makes theta with horizontal. So, VC is rightwards downwards, 43 degrees with horizontal. RC makes theta, that is 43 degrees with vertical. So, VC makes 43 degrees with horizontal. You must be able to locate ICR, and I have given you 3 cases to locate ICR. Remember those 3 cases. First case is rolling without slipping on stationary surface. Second case is V and omega given. And third case, direction of 2 velocities given. Now read this problem. At the instant shown in the figure, end B of rod AB is moving rightwards along the floor with velocity 6 meters per second. Determine angular velocity of rod and velocity of end A of the rod. Is it similar problem? Yes, it's the same problem really speaking. Only thing is, in the last problem with the ground, it was a wall involved. But in this case, in this case, there is an inclined surface on which the other end is resting. End B is resting on floor and end A is resting on inclined surface. That makes 45 degrees. So, what information we have here? Listen, B is sliding rightwards on the ground, and therefore, of course, A must be moving downwards again, but along this inclined surface. Velocity of point A, we don't know magnitude at this stage, that is to be found out, but we are sure about the direction. What is that? Downwards, that is rightwards downwards along the surface, and surface makes 45 degrees, that means VA makes 45 degrees with horizontal. So, to locate ICR, let us continue with the procedure. 2 linear velocity vectors are known, VB and VA. So, these are the 2 surfaces. Inclined surface makes 45 degrees with horizontal, and here it is that rod AB. Rod AB makes 30 degrees with horizontal. Angle of inclined members always required, remember. So, rod AB 6 meters long. So, this is length of the rod. Now, show velocity vectors, known velocity vectors. Don't forget to write this statement, because in the diagram we are not going to use unit. for dimensions. We want very clean diagram so that we'll able to study geometry very easily. So Vb 6 meters per second rightwards, this is that direction of velocity of B that is given. Now direction of velocity of A, that is also known to you, because if B is sliding rightwards, A must be sliding along the wall in downward direction. Now draw perpendicular to VA at point A, draw perpendicular to VB at point B, where these two perpendiculars intersect, that is ICR. Now known linear velocity vector about ICR gives direction of rotation also. So it is anti-clockwise direction of rotation. We have found out ICR. What does that mean? At this instant, a rod AB is rotating about this point, IAB. I have labeled that point as IAB. Distance of B from center of rotation is RB and distance of A from center of rotation is RA. Which triangle has these two sides? You will be able to focus on the triangle. Now what information you have in this triangle? So two sides to be found out. So only one side is known, that is length AB. So one side is known means that two angles are known. Which are the two angles? So this angle is 60 degrees and this angle is 45 degrees. How come 45 degrees? VA makes 45 with horizontal, so we are sure that RA is 45 degrees with vertical. We have not found out this angle is known. Do you know direction of VA? Yes, VA makes 45 with horizontal, so RA makes 45 with vertical. And two angles are given, means third angle is also known, 180 minus 60 and 45. So RA upon sin 60, that is equal to 6 divided by sin 45, sine of opposite angle, and RB upon sin 75, RB upon sin 75, and you will get RA and RB. So this is how we have found out RA and RB, means we have solved the problem. Distances we know, that means ICR is perfectly known. Now start velocity analysis with known linear velocity. So VB is equal to RB into omega. Just put the values of V and R. You will get omega AB. Direction of omega AB is already known, anti-clockwise. So angular velocity we have found out. Simple. And we are also asked to find velocity of end A of the rod. So VA is equal to RA into omega. RA and omega are known. Just put the values and get the answer. So VA is 5.379 meters per second, and direction we have already shown in the diagram, but show it in the final answer. That's important. So we have solved the problem. You can find angle of any point on this rod now. Suppose you want to find angle of midpoint, suppose you want to find velocity of midpoint. So join midpoint with IAB, that is RM. VM is equal to RM into omega. So you focus on the triangle, use sine cosine rule and get the answer. It's that simple. Now we have solved two problems before this problem involving rods in general plane motion. In this case, there is a rod AB. So this problem, really speaking, is similar to earlier two problems, but it appears that it is a mechanism. What do you mean by a mechanism? More than one moving bodies are involved, connected to each other, and they can move with respect to each other. In this case, listen, this vertical rod here, it is fixed at both the ends. So it is fixed rod. At the instant shown in figure, collar B, here it is a rectangular block. It is collar. It is a rectangular block. It has a hole through which this vertical rod is passing. And vertical rod is fixed. Collar B can slide on this vertical rod. Like curtain rings move along a rod. So here rotating body is only one, and that is rod AB. Block B is simply sliding on this vertical surface. So block B is in translation. If body is in translation, then velocity of each and every point on the body is same. So velocity of each and every point on the block is the same, and what is that? 6 meters per second. This block and rod AB are connected by a pin here. That means rod AB and the block B can move with respect to each other at point B. Now it is pin joint, but it is not hinge support. Rod AB is not connected to external stationary surface directly by this pin. Don't think that it is a hinge support. It is not fixed hinge. Here it is pin joint, but it is not fixed pin. This pin is moving upwards. Do you remember, center of rotation is point of zero velocity. So because this block is moving upwards, we are sure that this pin means end B of the rod is moving upwards. So end B of rod AB is moving upwards. What does that mean? End A is moving upwards along this surface. It is sliding on this surface. At its end A, rod AB is simply resting on this inclined surface. So it is sliding on the surface. So even if there are two moving bodies, rod AB and block B, there is only one rotating body, and which is that rod AB. Why you are so much sure? Why are you so sure that rod AB is in rotation? The reason is B is moving, end B is moving upwards and end E is moving along inclined surface. 2 points on a body are moving in different direction, means the body is in rotation. So here rod AB is in rotation. Just to make you visualize the motion, focus on this diagram now. Collar B can slide on the rod. So collar B is sliding on the rod and end A is moving along the surface upwards. So this is the mechanism. So now focus on rod AB and show known velocity vectors on rod AB. So this is rod AB, 6 meters long. Dimensions are in meters. Surface makes 30 degrees with horizontal. So this line is the inclined surface, and now you can say it is path of end A. End A is moving along the surface. So this is a path of end A. And path of end B, that is end B is moving along the rod, vertical rod. So this is that vertical rod. So actually we have copied this diagram. Have you realized that? Only thing is, it is a line diagram. Rod makes 45 degrees with vertical. All given dimensions are always very important, and also angle of inclined members either with vertical or horizontal required, and angle of rod AB is given. Also information we have, B is moving upwards with velocity 6 meters per second, and we can visualize that A must be moving along the surface in upward direction. So this is VA. Now two linear velocity vectors are known in the diagram. So to locate ICR, just draw perpendicular to VA from point A. Watch carefully here, it is not perpendicular to the rod, it is perpendicular to VA. Draw perpendicular to VB at point B. Where these perpendiculars intersect, that is ICR. It's similar to earlier two problems. Known linear velocity vector about ICR suggests anti-clockwise direction of rotation. Distance of A from center of rotation is RA and distance of B from center of rotation is RB. Now which triangle has these two sides, RA and RB? You will be able to focus on that triangle. What information we have in this triangle? Only one side. So if one side is known, you must know two angles. Let's check whether we know two angles. So this angle is 45 degrees and this angle is 60 degrees. Now how come this angle is 60 degrees? Remember, we have not found out it. We know it. VA makes 30 degrees with horizontal. So RA makes 30 degrees with vertical. Means RA makes 60 degrees with horizontal. This angle is 45 degrees. So two angles are known, means third angle is also known. 180 minus 60 minus 45. So use sine rule like in the last two problems. Get down values RA and RB. Easily you will get RA and RB. And now start velocity analysis with known velocity, that is VB. VB is equal to RB into omega AB. Just put the values. VB you know 6 meters per second. RB we have found out as 6.692 and we got omega AB. Direction we have already shown in the diagram. So angular velocity we have found out. And we are also asked to find velocity of point A. VA is equal to RA into omega AB. So VA is equal to 4.9 into 0.8966. So VA is equal to 4.393 meters per second at an angle 30 degrees. Direction is already there in the diagram, just show it in the final answer. So it's a very simple problem. Thank you.